Good. All right, what do we got today?
Alright, so just more of a review packet.
Okay.
Let's see here. Let's go ahead and do this one. Which of the following are antiderivatives of f of x equals cosine cubed x sine of x? And my options are f of x is equal to negative cosine to the fourth x.
Okay. I don't need the options. Let's go through how we do this.
Okay.
Okay. We're going to use integration by substitution. And what I look for when I'm looking for integration by substitution is here we have the product of two functions. And I know that the inside derivative is this. That is what makes it perfect for integration by substitution. Let me show you. We're going to let u equal cosine x.
Okay.
Now we differentiate that. Du dx equals minus sine x, which makes du equal minus sine x dx.
Okay.
Let me take this one step further. That makes dx equal du over minus sine x. So now I can completely rewrite this integral. I can rewrite this integral as u cubed sine x. There was a dx up here also. Well, dx is now equal to du divided by minus sine x. Notice how I get rid of the problem. In other words, I cannot take an integral of u if there's still an x in there. So the fact that that sine x cancels out with that sine x now leaves me, I got to do something with that negative sign, so I take it outside.
Okay.
Now I have a complete integral of u that I can easily integrate. What is the integral of u cubed?
1/4 u to the fourth.
Bring along that negative sign. So that's our answer. Now we resubstitute. Well, u was cosine x, so this is cosine to the 4x divided by 4 plus c if it's an indefinite integral.
Okay.
Okay.
So yeah, that's one of them. Let me see here. So,
there's something very specific that you look for when you're looking for integration by substitution. That is, in other words, the problem here is what to do with the sine x. Well, it turns out that as long as the derivative of the inside is the same thing as that, it's going to end up in the denominator like it did. In other words, the derivative of the cosine was minus sine x, and it ended up in the denominator, which means it's going to be canceled out by this sine x, and I'm going to be left with just u. And I can integrate just u.
okay, so one of the answers is sine squared x over 2 minus sine to the fourth x over 4, and that is apparently one way it equals this too. And I don't understand how she got that.
Okay, sine squared x what?
Over 2 minus sine to the fourth x over 4.
That's supposed to be the same. That's supposed to be the same thing?
Yeah.
Okay, let's factor that. I'm going to take out a sine squared x. What am I leaving behind? 1 minus sine squared x. And I'm going to take out a 4, or a 2 rather, also. So now I need a 2 under that. Well, 1 minus sine squared is cosine squared. You're saying that of your multiple choices, that was deemed the correct answer?
That was one of them. Yeah, it was which of the following are the antiderivative of this, and then it was number 1, number 2, and number 3, and all 3 were correct.
Okay, I got it. So we need to use a trig identity to turn this into this. Well, let's see. I think we can do that. We're just going to convert everything to 1 minus cosine squared, which is equal to sine squared.
Okay.
Well, let's go ahead and expand this. So we got 1 minus 2 cosine squared x plus cosine fourth of x all over 4. Over here we got 1 minus cosine squared of x, which I'm going to multiply both of these by 2 so that I have a denominator of 4. You with me?
Yeah.
Okay, notice what I'm left with in my numerator. The 2 cosine squareds of x cancel out, and I am left with 1 minus cosine fourth of x over 4. What was our first answer?
Well, that's one of the answers. That's the third option, and that's also an answer, but I still don't understand how you get it into the sine squared x over 2 minus sine fourth x over 4.
Well, did you see how I just converted that to this?
Yeah. But I don't get how you went from negative cosine to the fourth x over 4 to sine squared x over 2 minus sine cube, or sine to the fourth x over 4.
Well, I didn't. I worked backwards. I went the other way. In other words, this is the answer I got right here, right?
Yeah. Yeah.
That's one of your answers, minus cosine to the fourth of x over 4?
Yes.
Well, that's cosine squared times cosine squared. So instead of cosine squared, I'm going to use 1 minus sine squared.
Okay.
Now I can separate that. Well, actually, let's multiply that out. So we get 1 minus 2 sine squared x plus sine to the fourth x all over 4 with a negative sign there.
Okay.
That's pretty close to what your answer was, wasn't it?
It's close. I mean, it
Sine
needs to
squared
be,
x over 2 minus sine to the fourth x over 4.
yeah.
Sine squared x over 2. Well, sine squared x over 2 minus sine to the fourth x over 4. Well, this minus sign is going to distribute to that, so there's my sine to the fourth x over 4. And the rest of it becomes 2 sine squared x minus 1 over 4. So I've got this. And,
Okay.
and 2 sine squared x minus 1, I think that's the cosine of 2x. Was this one of your answers?
No.
But it was this, right? In other words, I can divide top and bottom by 2.
Yeah. But there wouldn't have been a minus 1 on the top.
Well, and I need to do that anyway. I'm not sure why we're not getting this to I'm not sure why the trig identity isn't working. But I don't know that you and I want to spend our time on trig.
Yeah.
We'll probably spend it on calculus.
Yeah. Okay,
So
then let's do the derivative. Oh wait, no, I can get that one. Let's see. All right. So the function f is given by f of x is equal to 3e to the sine x.
3e what? Oh, like this?
Yeah, 3e sine x, yeah.
Okay.
And then, so over which interval is f decreasing?
Okay. Well, f decreases when what? The first derivative is,
Negative.
so let's find the first derivative.
Okay.
Take the derivative of the outside, multiply it by the derivative of the inside. What's the derivative of the outside?
0.
3e to the sine x. Okay? The derivative of the inside, in other words, let's go ahead and use u substitution here just to make it clearer. U equals sine x. That means du dx equals cosine x. So to take this derivative, I got to take the derivative of the outside, which is to say take the derivative of 3e to the u. Well, that's just 3e to the u times the derivative of the inside, cosine x. So there is my first derivative. I want to set that less than or equal to 0.
Okay.
When is that less than 0? Again, a trig problem.
Yeah, she has a lot of these, which doesn't make sense because it's a baby.
Is e to the sine of x ever negative?
No.
So the only way this can be less than 0 is if that's less than 0.
Okay.
Well, that's less than 0 between pi over 2 and 3 pi over 2.
Okay. All right, cool, yeah, so then 13 would be that. Let's see. Okay, yep. All right. Let's see. All right. So if f of x is equal to the integral from -10 to x squared of the square root of 1 plus t squared dt, then f prime of 2 equals what?
Okay. Let's first of all talk about what f prime of x is equal to. Okay, there is the fundamental theorem of calculus says that f of x is equal, if f of x is equal to some constant to x of some function, then f prime of x is merely equal to f of x. That's what the fundamental theorem of calculus says. Well, the only difference between this problem and that problem is we're going to x squared. So when you're going to x squared, you need to multiply it by the derivative of that, which is 2x. So let's do that here. In other words, our answer is going to be, this could be -10, this could be 10, this could be 1,000,000. It doesn't matter. As long as it's a constant, then the answer is square root of 1 plus x squared times 2x.
So would it be x squared squared?
No. Square root of that times the derivative of this, 2x.
But wouldn't you plug in x squared for t?
No. You wouldn't. Hold on. I'll look this up. Let's see. This is the fundamental theorem. What chapter is that? 277. You might have a point. You might have to plug in x squared for t. I'll let you know in 2 seconds. Yes. So it's x to the 4th. Excuse me. You do plug in x squared for t.
Okay.
Yeah, because basically you're using u substitution also. In other words, what we really did was we let u equal x squared, and then it's -10 to u, so it becomes 1 plus u squared, which becomes 1 plus x squared, or 1 plus x to the 4th.
Okay.
And that variable, it doesn't matter. This is a dummy variable here. That could be t dt, that could be r dr, it does not matter. No matter what variable is there, this is true.
Hello?
Yeah.
Okay, so say that again?
No matter what variable is there, it is true. In other words, if f of x is equal to a to x of f of r dr, regardless of what this variable is, f prime of x is equal to f of x.
Okay.
Well, hold on.
Okay.
Yeah. Actually, I didn't state that quite right. Let me do this. The derivative of this relative to dx is f of x. In other words, when you take the derivative of an integral of a function, you get the function in the new variable, which is that. And it doesn't matter whether this is an f of r dr or an f of t dt or some other variable. When I take the derivative of this integral and I go from a constant to x, I'm going to get f of x. This is basically the fundamental theorem of calculus, part 1. In our case, we went to x squared, which means we had to plug in x squared wherever we found x or t or r.
Okay.
Yeah, we got time for another quick one if you have it.
Okay. Don't know how quick this one is going to be, but the graph f of x is equal to x minus 4 cubed times 3x minus 1 cubed and has a local minimum at x equals. So I need to find the x value of the local min.
Okay. Did I write this function correctly?
Yes.
Okay. So to find the local min, what do I want to do?
You need to find the first derivative, set it equal to 0, and then the first derivative test.
Okay. What's the first derivative of this?
Use
the product.
X minus 4 cubed.
Let's use the product rule.
Yeah, so x minus 4 cubed, because wouldn't you do, and then multiply it by the derivative of the 3x plus 1, or minus 1 cubed.
Okay. What's the derivative of that?
So 3 times 3x minus 1, and then chain rule times 3.
Squared times 3.
Times 3.
Okay, so that's the first part of the product rule. What's the next part?
3x minus 1 cubed times 3x minus 4.
Squared.
And then it would be multiplied by 1, but it doesn't matter.
And squared.
Yeah.
Okay, so this is what I'm setting equal to 0. First thing I'm going to do is move this to the other side. So I'm going to set it equal to 0, and then I just have an algebraic expression.
Okay.
That I have to solve. And there's a negative in front of that. All right, let's see. I got an x minus 4 squared that I can cancel out with everything but one of these. In other words, I divided both sides by x minus 4 squared. Then I have a 3x minus 1 cubed and cancel out all of that with everything but one of those. So now what do I have? I have minus 9x plus 3 equals 9x minus 36. Well, that's easily solved. 18x equals 39. X equals 39 divided by 18.
Okay. All right. Cool.
All right, Kelly. When's your final?
That would be tomorrow.
Tomorrow. Good luck.
All right, thank you so much.
All right, Kelly.
All right.
Bye-bye.
See ya.